answering the question 7 for STA 116 June 2018, I believe. So for the part A, the number of visitors to a web server follows a Poisson distribution. If the average number of visitors per minute is 4, calculate the probability that there are at most 2 visitors in 1 minute. So in this sub question Roman 1 here, we have to take note that the time interval has not changed, so we can use the lambda where lambda is 4, and then it wants at most 2 visitors in 1 minute. This is equivalent to probability where x is less than or equal to 2. So it is also equivalent to p where x is equal to 0 plus p where x is 1, and plus probability where x is 2. Okay, by combining summing all of this together, you will get the probability where x is less than or equal to 2. So in this mathematical notation down here, this is what I will input in the calculator for faster results, and then you have to, but in this video we will input the values manually. We will input the videos one by one. So from this is the formula for calculating the exact probability. The lambda is to the power of x times e. The e is a constant, e to the power of negative lambda divided by x factorial. So you put the values there. You put the necessary values. It will be 4 to the power of 0 times e to the power of negative 4 divided by factorial 0 plus 4 to the power of 1 times e to the power of negative 4 or divided by 1 factorial plus 4 to the power of 2 times e to the power of negative 4 divided by 2 factorial, and then you will get 0.0183 plus 0.0733 plus 0.1465. This is the probability where x is 0, this is the probability where x is 1, this is the probability where x is 2, and summing out together you will get 0.2381. So for the sub question Roman 2, you will get it asks you for the probability where there are exactly 2 visitors in 30 seconds. That means we have to find the new lambda because it has a different time interval. So the new lambda, to calculate the new lambda, you have to divide it by 2, because in the original question, the original question, it says 4 visitors per minute. Per minute is 60 seconds. So 30 seconds is half of a minute. So 4 will be divided by 2, which we will get 2. And then for p, okay, this is just the formula. Lambda to the power of x times e to the power of negative lambda divided by x factorial. And then it asks for the exact value of 2 visitors within 30 seconds. 2 times 2, we get the lambda here, 2 to the power of 2 times e to the power of negative 2, and then divided by 2 factorial, you will get 0.541341139 divided by 2 factorial, and then you will get 0.2706. If you try to round it, you will get 0.2707. So that is the probability where there are exactly 2 visitors in 30 seconds. So for the sub question number 3, it wants the expected number of visitors in 3 minutes. So because there are 4 looking at the original question, there are 4 visitors in a minute, then if then within 3 minutes you will get 12 visitors by multiplying 4 and 3. Moving on to the part B. Suppose mass produced needles are packed in boxes of 1000. It is believed that on average one needle in 2000 is defective. Using an appropriate approximation, calculate the probability that a box contains more than 2 defective. So from this question, you can say that we can get the value of n, which is 1000. The p is 1 over 2000, and the q is 1999 over 2000. You will get it by 2000 minus 1, and then you will get 1999. Okay, by looking at the value of n and p, since n is over 50, which is 1000, and p is less than 0.1, which is obviously p is less than 0.1, then x follows the Poisson distribution approximately, where np is the mean value. So n is 1000 times 1200, and then you will get 1 over 2. That is the mean value, and also the lambda value. And then you will get the lambda value here. Just put it here, and then the question want us the probability where the box contains more than 2 defective. Okay, so obviously we cannot count like this. We cannot calculate the probability like this. We have to do like this, where 1 minus p x is less than 2. This is the correct way of doing when it asks for more than, because there is infinity, I believe. And then 1 minus p where x is 0 minus p where x is 1. So you put in the necessary values using the same formula in part A question. You will write 1 minus 1 over 2 to the power of 0 times e minus e to the power of negative 1 over 2 divided by 0 factorial minus 1 over 2 to the power of 1 times e to the power of negative 1 over 2 divided by 1 factorial. And so you will get 1 minus 0.606530657 minus 0.3032653299. So the 0.6 here is the value for the p probability where x is 0, and 0.3 is the probability where x is 1. And so you, after minusing them all together, you will get the final answer, which is 0.0902. This is also have similar answer in the table. So I have already checked it, but I forgot to put it. So